Okay, the real number set. Here we're gonna talk about bounded above, upper bound, and the maximum element of a set. Let's take a non-empty set X, non-empty set X, which is belongs to real number set, and simple X is an element of this set X. If there is a real number M such that X is less than or equal M for all X belongs to this set X, then we can tell this set X is bounded above, and also we can tell M is the upper bound of this set. There is a real number n such that M should be all the element of this set X should be less than or equal M. Then we can tell X is bounded above, and M we can call it as the upper bound. And also, if M belongs to the set X, then we can tell the maximum element of this set is X, M. We denote it as max X equals M. Okay, let me to draw the real number line. This is the set X, capital X. These are the elements of this set X. Here is the M. We can say geometrically, we can say X is bounded above if there is no point of X the right side of the M, then we can tell X is bounded above. That means simple X are the elements of the set X. There are no any elements right side of the M, so we can tell X is bounded above and M is the upper bound. If M belongs to the set X, then we can tell M is the maximum element of X. Okay, let's take examples. Here, first example, x1 equals open bracket from minus infinity to 2. Okay, here we can clearly see all the elements of this x1 set is less than this 2. So we can tell x1 is bounded above. And also we can tell 2 is the upper bound of the set x1. And since here 2 is not an element of x1, we can tell 2 is not the maximum element of x1. Okay, let's take the next example. Here x2 is equals 1 minus 1 upon n for n equals 1, 2, 3 likewise. Okay, let's take the elements. When n equals 1, here the answer is 1, then the answer is 0. When n equals 2, here the answer is 1 upon 2. Likewise, when here n equals infinity, here the answer is 0. So 1 minus 0 means 1. Okay, then clearly here we can see all the elements are less than or equal 1. So we can tell x2 is bounded above. And also I'll write here, and also with this part we can tell 1 is the upper bound of x2. Then since 1 is the element of this set x2, we can tell max x2 is equals to 1. Okay, when we let's take the next example. X3 equals n square for n equals 1, 2, likewise. Here clearly we can see no limit for this set, because here n square, it can be goes to the it goes to the infinity. So here clearly we can tell x3 is not bounded above. Okay, here the speciality is there can, if a set is bounded above, there should be a upper bound. So here also, here x3 is not bounded above, so no any upper bound or no any maximum element. Here if the set is bounded above, there should be a upper bound, there should be an upper bound. If that upper bound is belongs to this set, then we can tell there is a maximum element, so then the upper bound is equals to the maximum element. So here we can see here 2 not belongs to x1, so 2 is not the maximum element. So here 1 belongs to x2, so here the maximum element is 1. So okay, let's stop. Let's continue the real number system from another video. Thank you.